Panelists, are you able to hear me?
Yes.
Good morning, Ankesh. Thanks
Good
for
morning.
accepting our request to conduct a webinar on building web API using ASP.NET. I would just like to give a brief introduction about you. Mr. Ankesh Maradia, he is co-founder Track Gaddi, owner at Extreme Thoughts Softtech, which is working from Surti iLab, and he was an ex-assistant vice president at CSIPL, that is Citibank Group, and manager at TCS. He is going to talk something technical about web API, what are their usages, and how it can be made and used. So now I give over to Mr. Ankesh.
Thank you, Anshu, for the introduction. Good morning, everyone. So I hope you are having a good morning and all are safe at home and following the government uh, orders or the guidelines for the COVID. And I hope you all stay safe. So I'll I'm Ankesh, and Anshu has given the introduction about myself. So what we'll do is we'll start looking at the web API. So sorry for my webcam. My webcam is not correctly placed in laptop, so I cannot do much about it. But what we'll do is we'll learn about web APIs, the basics of web APIs, what is API, what are the different protocols, and then we'll build upon how to build that, what are the various usage, what are the various artifacts of the web API, and then how it can be hosted, what are the design patterns, and all those are related to it. And then at the end, we'll see. Okay, is my voice clear?
Now it's clear.
Okay, is it clear? Okay, thank you. All right. So what I'll do is I'll directly jump into the presentation and we'll start going through the slides. And if you have any questions, feel free to type in the chat box. So if the question is related to that slide, I can cover it right there. And at the end, we will have question and answer session. So all your questions can be answered there as well. So I'll start the session. Okay. Can you see my screen? One of the panelists, can you confirm?
Yes, we can see the screen.
Okay. So what we are going to cover it today. So first we'll understand what is the API, and we'll understand the terminologies which are related to API and web API. We'll look at what is web API, then where it can be applied, what are the usages. We'll look at the technical details of web API pipeline, what all features web API do. We'll have a code walkthrough as covering this entire topic in through all the artifacts. It takes a lot of time, but what we'll do is we'll have a code walkthrough so we can at least get a feel of how it look like, what are the different places where we write what logic. And then we'll see some of the architectures or design patterns which we talked through in this design and in this session and looked at in the code. Also, we'll see how the web APIs can be hosted, and we'll end it with Q&A. All right. So first question is, what is an API? So API is kind of a term which you will hear everywhere. So whatever, if you talk to someone, okay, this can be accessed by API, that can be accessed by API, this can be done by API. But what is an API? So API is an application programming interface. Okay, it's kind of a basically an endpoint where system allows you to interface. So a software allows other software or other pieces of that same software to interface with that software. So what it does is it works on the set of routines or protocols how you can talk to that particular software. So let's say if you want to get some data from Google, or let's say you have a latitude and longitude and you want to get address of that. So what Google does is Google exposes an API where you can say that give me the address for this latitude longitude, and Google will give you with the response. So that way you don't really need to know about how Google is getting the address and what are the data structures and what are the complexities inside Google, but you just have an endpoint or the interface. That's a very basic example that you give some input and you have an output. You don't worry about what it is internally doing. So for the end user, it is the interface which only matters. Okay. So is this API new? No, I would say this API or web APIs, the concept is there since long. So, so in the previous systems, the API or the interface would be the TCP channels or the socket communication. So those are also an API. It's an interface which allows you to kind of communicate with the software system. So now, so that's kind of a very restrictive in a way. Uh, you can use or maintain that. Now there are new ways of are doing that. After those socket communication, there is a layer on. So everything works on socket. So socket is not going anywhere. But instead of directly communicating over socket, when the web came or the web became popular, web services became popular. So web services also what it does is it exposes an endpoint, which says that you if you call this in this format, will give you output in this format. So web services uses SOAP as a protocol, and it uses the XML as a data transformation uh, kind of a notation for storing or transferring data. It uses XML. So we'll look at all these terms: what is SOAP, what is XML, and in brief details when we look at the terminology. So that's about web services. Now, web services does the function, but it in terms of architecture wise, it has limitation. Also, in terms of performance wise, it is bit heavier in terms of it has a header, message, and XML, and so all those had a kind of a impact on the performance and the architecture of the system. Then the thing came up or thing became popular was REST services. So REST services are not new. So REST as a concept is there since I guess 2000. So, but the REST services that implementation of that using kind of a I think I can see some reason. Do you have any question? Do you have any question? So if you have any question, just type it. I cannot see any kind of a question being typed. So what I'll do is I'll move on. And if you have any question, you can type and I'll answer it when in the session, during the session. Okay. So that was web services, and then the the concept of REST. Now REST service is an architectural pattern, so which works on HTTP, and it can use XML, JSON, or other formats as well in for data transmission. So in Web 2.0, REST services is kind of a very essential part of it, or critical part of it. And Web API is majorly used to develop RESTful services. So we'll see what all these terms are. Now, what is HTTP? So everything on web, if you see, majorly works on HTTP. It's a hypertext transfer protocol. It's a protocol which which allows you to kind of a collaborate between systems. It allows you to get the information over the web. Now, what is REST? REST is representational state transfer. So as I said, it's an architectural pattern for creating that uses HTTP as a communication method. So as REST is a pattern which internally uses HTTP. A lot of other protocols also, or the patterns also uses HTTP in the enter, because that's a protocol widely used for communicating over the web. So REST is the architectural pattern. SOAP. SOAP is Simple Object Access Protocol. It's a messaging protocol, and as I said, that web services uses SOAP, and it uses XML for its message format. Now we also looked at few terms like JSON. Most of you would be aware, but I'll just cover this if some of you is not aware about it. So I just thought that we'll cover the terminology, so we are good. So JSON stands for JavaScript Object Notation. So it's a syntax for storing and exchanging data. So is XML. XML stands for Extensible Markup Language. So it's a markup language similar to HTML. So you can define tags and all, and it is also designed to store and transport data. But if you see, if you generate a XML, or if you put some data into XML and you put same data into a JSON, you'll see JSON is kind of a lot more light in terms of transfer or the performance. So the size is also less. So if you see, if you transfer a less file, you get the performance. So the JSON helps us in kind of getting the performance, better performance. Now, what is a resource? So you'll hear this term resource uh, during the session. So resource, so a web resource or a web resource. It's the same terminology in terms of that. A web resource is anything that can be obtained from World Wide Web. So some examples are the web pages. So web pages is your kind of a resource. Email is a resource, or information which you are storing in the database. You want to get that. That's a resource. Web services are the resource. So all this think of as a resource, or an image if you want to download, that's a resource. So everything is a web resource. We'll also see this kind of a concept called hate OS. So this is an kind of a we'll see the various phases of uh, kind of a the communication between client and a server, how it can be done, what what were the old ways and how it transformed to the new ways. So hate OS is a kind of a latest, and it's very useful in terms of how you can communicate or transfer data. So hate OS stands for Hypermedia as the engine of application state. So it means each request there will be set of hyperlinks that lets you to do what action you can perform on that resource. So now just give you an example. So if you are getting list of customers from an web API call, you will see understand that. But let's say if you get a customer, now with that customer you want to get more details about the customer, you want to create new customer, you want to update some data of the customer, you want to delete some data of the customer. So you or the application should know, okay, how should I do that, or how can I do that? So they need an kind of a resource, or the so resource, so that's a resource. So getting a customer, or deleting a customer, or creating a customer, each of this is a resource. So now how the resource are identified? So in web, resource are identified using URI, that's a uniform resource locator. So you all of the resource as a URI. So now in hate OS concept, when you get the list of customer, or particular customer, it gives you the links related to the customer operations. Like if you want to do update a customer, so what is the URI for that? So you get with the object itself. So on client side, you don't have to worry about configuring a lot of URIs, because URIs can be trickier to handle. And suppose let's say some of the URI changes, or let's say if you change some URI pattern on the server side, everything on client side changes or breaks. So in this, if client side, if you haven't configured the URI on the client side, then the chances of breaking it are very less. So you just configure one for getting the list of customer, and then the further things are dynamic. So we'll see how it goes. Okay. So now this is a kind of a very simple chart, and I'll show you the calls how it goes through. Okay. So over here we see the 4 levels. So level 1 is POX, that's a plain old XMI. So how we used to communicate or the make calls or interface systems in the level 0. Then we kind of understood few more things about it, and then we started using resources. Then we kind of graduated a bit more, and we started using HTTP verb, so we can give meaning to each call. And then we started using Hypermedia Controls, which is essentially HATOS. Okay. So in plain old XML, if you see this, so from blue is the client system and the green is the server. So on client, if I want to see that what are, so this is giving, or this is an example for knowing the open slot for appointment booking and booking the appointment. So on green side, this is a kind of a service which exposes an endpoint which says that okay, we'll send a request, give me the open slot, it will return. On the same endpoint, we'll say the okay, these are the slot, I want to book appointment for this slot. So you see over here is a single endpoint for all the requests, and the request details, we have to know the request details or inside to know okay what operations needs to be performed. So that XML gives on kind of a tells us what the request to be performed. So now this was doing the purpose, but if as the more and more APIs or more and more requests are there or the functionalities are there, this gets really complex. Then we move to next level. So instead of, if you see, we had appointment service as a single endpoint. On the second level, you have different 2 endpoints. One to say that okay, doctors, for this particular doctors, can you tell me the open request or open slot? You get the open slot, and on the second request, you say okay, slot number 1, 2, 3, 4, I want to book it. So here, each kind of a doctor or slot, all these are kind of a different resources. So in XML, we were exposing at a single service. Now we have a link or endpoint for each resource. So, but if you observe, all the requests are kind of a post. So we are just posting data. So now we kind of matured a bit more, and we started using appropriate HTTP verbs and the responses. So here, if you see, the response is always the request is post with some data and response is some data. But over here, if you see, the request becomes now get, and with what you want to get. So the URL tells us okay what we are kind of requesting. Okay, for doctors, the San Johnson slot, and response, if you say there's a 200 okay. Previously, if you see, it just written some XML, but now it has 200 okay. So 200 okay. All these are HTTP codes, which we will see what are the different type of codes and what does those signify. So get it, we send the get request, we get 200 okay. Now we get the post request, and we get 201. So this is different HTTP verb or the status code, which tells us okay what was the status of this request. And if with 201 created, it sends the URI for the resource created. So if you want to get the details of this resource, you can use this location or URI. So now we were using verbs, so we are all good over here. But if you see, we should know what is the slot endpoint to make a request. So now with Hypermedia Controls or the HATOS pattern, if you see, we are making the GET request similar to what we did with the HTTP verb. Over here, we make the GET request and response we get the 200 OK. But with that, we also get the link. Here we say that this is the link for slot booking and this is the URI. So we can use this link dynamically to call it to book the slot. So client side, we only have one URI, which is to get the slots, and then all the slot creation, deletion, and all the links are kind of generated dynamically. So which gives us immense control in terms of maintainability and let's say. So how this is useful is, let's say if you host or if you decide to host all your services into different server or different URL, the client doesn't depend on knowing okay where you deployed or where the movement was done. So all this is pretty dynamic and it's pretty magical. Okay, so that was we saw over here the plain old XML. Then we started using resources, and then we gave some terms or some we started using proper verbs for those resources, and then we went all dynamic in terms of okay where is the resource and all. Okay, in terms of failure, if you see, yeah, so that's a good question in terms of failure. So I'll show you if something fails, what happens. Okay. So working with HTTP verb and return status. So your question about failure will be covered when I cover the return status. So over here, if you see, we used get, we used post. So there are other verbs as well. So there are total 9, but generally this 6 are majorly used. So get, so for getting some information when you are requesting, so you are not changing anything, you are just saying that give me open slot. So that's a get request. Head request is generally it's not used in programmatically while you are getting some data, putting some data, but it's just to know okay whether this exists or not, just as a check. Post, when you want to create some new record, so you want to book an appointment, so you are booking a new appointment, so that's a post. So all these verbs are very important to understand and listen carefully when to use what verb. For getting data, we use get. When we are not modifying any data, we are just getting the data. When we create a new record or new data, we use post. Okay. So post is used when we create a new data. Put is generally used or put is used when we are updating an existing resource or existing data. Okay. So when we are updating any data, put is being used. Delete is being used when you are deleting the data. And patch is used when you are updating part of the data, not the complete data. So if you want to just, let's say for an appointment, you just want to put some comments, so you use patch for that. But if you want to update all the entire appointment record, you use post. So there's a slight difference between put and patch. Okay. Now, so this is all about when we are making request. So when we are making request, what verbs we should use. Now, another is whenever somebody makes us request or some system makes us request, we should use standard HTTP return status to tell what happened. Okay. So generally, when you hit on a website and you type google.com and page displayed, but if you look at the behind, it is sending 200, which is okay. So we return you the resource as well as everything is okay. Now with post, when you are creating a new request, we generally say that yeah, everything is okay and this is the link. So we send 201. So this terminology or this status code, if we use in API communication, that's the standard way of doing it. Now let's say you make some request or some resource which doesn't exist or the valid is not doesn't exist, but the URI itself is not good or the data you are passing in that URI is not good. Then you return the 400 code. That's a bad request. Now let's say, uh, so there's no full form of put and patch. At least I'm not aware of that. So put is, it's a word, right? If you're putting something, you're updating something, and patch is you are updating a portion of it. You are not updating the entire list. Okay. So return status. So 200 series is generally all good. Everything is good. 400 series tell 400 or 401, 404, 409. So this indicates something is wrong with what you are requesting for. Either the request is bad request, which is 400, or you are not authorized to do this request. That's a 401, unauthorized. Or what you are requesting, that resource we are unable to find. That's 404. Or what you are trying to do, let's say if you are trying to update something, or you are trying to update a particular data, and that cannot be done as per business rule. So you return appropriate kind of a code for that. So which is 409. It's a conflict because business rule cannot allow you to do that. So 400 series is when something is wrong with what you are requesting. Okay. 200 series is like 200, 201, all is good. Now let's move on to 500. So 500 is internal server error. So something which, while processing a request, something went wrong on the server side. So some error exception occurred or database connection failure. It can be whatever. So in that case, 500 is written, and if something is not implemented, you return 501. So 500 series tells that something is not good over there on the server. Okay. Someone asked about, is there any logic behind selecting the specific number? So, so all these numbers are part of a HTTP protocol. So this when a protocol is written or defined, you have rules, right? If you want to do this, okay, do it like this, because having a common number or common kind of a written status is easier for system to collaborate. So it's like widely across all, we have same number, same numbers. So everyone knows, okay, what does 200 mean? You don't have to kind of know any internal logic. I hope that answers your question. I'll move further. Okay, now what is ASP.NET Web API? So we'll revise a bit. So we understood what an API is. API is an endpoint or interface to a particular system or particular module. Okay. So now there's a, for communicating it using HTTP, so we have set of protocols which we can use. So REST is one design pattern we can use to implement that. And we also understood about what are the different ways the calls are made and how the calling mechanism evolved. We also understood the various verbs and states. So now let's understand what is Web API and how everything comes together in Web API. Okay. So ASP.NET Web API is a framework for building web applications that is HTTP-based services on top of .NET framework. So if you, so we had WCF in previously for, initially we had web services and to kind of allow or develop services based on HTTP. Then we had WCF, which also allows kind of a RESTful development, but it lacks some of the capabilities which Web API has, and it's very cumbersome to configure and manage. So if we want to do RESTful HTTP communication, Web API is the framework to go for it. But most of the things which we can do with Web API can also be done with a lot of other frameworks. WCF is one of them. But if you want to have full control, maintainability, robustness, and a lot of features, Web API is the way to go. So Web API framework is widely used to create RESTful services. Okay. So moving further, okay, we yeah, as we talked about, that web API, everyone talks about API. So we understood what API is. Now where it is used almost everywhere. So whatever whatever interaction between two system or two components we need to do, it's an API. And if this interaction is over the web, it's web API. So it is basically used to interface two systems. So now where it can be used. So now let's say if you develop a particular web API and you want to call that from your ASP.NET Web Forms application, you can do that. If you want to call that from Angular, you can do that. If you want to call that from Knockout, you can do that. If you're developing single page application, okay, where your page loads once and after that there is no more loading. So like typical web application, we have when we click on particular link, it moves to next page, and when we do something, it moves to next page. So the entire page are kind of a posted back. But with single page application, all your HTML is rendered or the loaded at once, and you just make kind of a API call to get the data or to perform the operation, and you use various templates on a different framework to change the UI. But for single page application, web API, you cannot develop single page web application without web API, right? Because all the communication happens asynchronously behind the scenes. The page is not posted. So you need endpoints, separate endpoints where you can talk with. And it gives you a lot of performance as well because it saves the entire round trip of the posting the page, loading the page again and all. So everything on client side, you just kind of do the piece which is required. Like if you want to create some data, you just make a request with that data and it will be super fast. Mobile applications, all the mobile application development, they are using APIs, right? So whatever data they know. So we generally don't keep too much of logic on mobile application unless it is a gaming or it which requires a lot of client side processing. So which we try to keep mobile application lightweight as much as we can. So with mobile application, if you want to get some data, you call the web API. Desktop application, you can call web APIs. In fact, even the IoT systems where from firmware and all, or their native OSs, you can call web APIs because those are very lightweight and it's very simplified in terms of calling. So web API, a single web API can be called from your ASP.NET Web Forms, your Angular application, your mobile application, your desktop application, and IoT application. So you see, a single endpoint can be consumed anywhere you want. So it opens your kind of options like plenty. So you write your business logic inside API, and you can give whatever form or UI form you want to anywhere in different kind of vectors of the. Okay. In terms of IoT application, so over here, so let's say I'm not very much expert in IoT, but we have done some of the development. So especially for our startup, so that's an IoT based startup. So we have that particular GPS based communication. What we do is that there is a device which sends data to the server. So over there is an option that data calls particular API. So that same API can be called from IoT devices. So basically, wherever you want to perform kind of a data transfer with system, you can do that. So in IoT, what are the different factors and what are the different kind of OSs and all? I'm not much aware about that, but let's say understand it like this: if you want to do a data communication across the web, very lightweight, very reliable, and very fast, then web API or the RESTful APIs are the way to go. So moving on to further. So we'll look at this pipeline at high level, at conceptual level. And then when we look at the code walkthrough, this all things will hopefully get clear. So what's in web API pipeline? So it's kind of a life cycle you can consider. What's in life cycle? So HTTP request comes. So there's a set of middleware. So middleware is kind of a set of functions which does the pre-request processing, or they do the request redirecting and all based upon what request is there. Then it so once middleware processes that request, it sends and it determines. So let's say okay, so now this processor this request has came. I have understood this. I have processed this. Now this needs to be routed further for handling. Then we'll route further. If not, we'll just return from there. So now let's say if we are making an API call to get the resource, to get let's say list of open slots which we talk about further or the previously. So middleware gets that request, it understands okay, this needs to be routed. So it sends it to the routing kind of a handler. So routing handler understands the request. It kind of identifies which controller needs to be called for this request. So it identifies the controller. It does the controller initialization and says that okay, invoke this method or action method. So after routing, controller initialization is done. Okay, so whatever controller required, so whatever are the controller parameters or whatever uh, additional services are injected to that controller. So we'll see this injected or what is injection. Okay, so that's also a kind of a concept which is pretty much required everywhere now if you want to write testable code. So controller initialization is being done. After that, action method is called. Action method is a method where actually write your code to get the data. Obviously, it uses different kind of a layers as well in further or the in your pattern. But in terms of your endpoint, action method is your endpoint or the URI. And then once it is executed, you get the result and you return the result. So the result can be data result or it can be the view result in terms of MVC or other framework. So you can either return data or view and then it is responded. So if we understand simply, the request comes, middleware does some of the processing like HTTP filtering and the data type filtering and the content negotiation. So all these are concepts which we'll kind of talk about further. And then it does the routing. Routing identifies the controller, initialize the controller, executes the method, generates the result and return. So that's a very simplified pipeline. So any questions so far and anything which you want me to kind of repeat or explain again?
Yes, Ankesh, there was a question from the participant that what happens if we get disconnected while making communication through the web?
Yes, so that I think I answered that. But let's say if I'm making some call and internet got disconnected, your call failed. So on client side, you will know that that you are unable to connect, so you have to handle that particularly. So now if something so, so this web API or the on server, if there is a connection issue, if request doesn't reach server, we cannot do anything on API. So it's a transport layer or the connectivity issue which needs to be handled on client side. Now, but if the request reaches the server and from server, if there is any connection issue with database or any other services with server from server which we are using, then that handling we need to do on server and will return the appropriate code. Like it can be finded that internal server error. We are unable to process your request. We will notify client that finded has so finded or internal server has happened and we are unable to process your request. And when the client gets the finded, client knows okay, finded or something is wrong on the server. So it will give appropriate message to user or it will retry again or so that's the client logic.
There is one more question.
Mhm.
Can you discuss some more examples related to IoT?
Yeah, so that I try to cover. So in terms of IoT applications, IoT application can be varied, but in terms of how it can call APIs is wherever you need any data transformation over the web, you can use API. So it can be like for GPS tracking, you want to continuously send the status of the uh, particular vehicle or particular device, you send that via API. Or it can be something like some other sensor, thermosensor, thermostat sensor. You want to continuously send what's the uh, temperature of that. You can send that data via API. So whether API can be kind of a call from each and every firmware, I'm not sure. But let's say wherever data there's a data transformation requirement, and it can be done over the web API, you can use API to do that.
Okay, we can continue.
Okay, thank you. So this is a simplified kind of a pipeline. Now we'll see the little complex part of it. So don't worry if you don't understand any piece of it. So, but let's try to go over it and understand, or at least be aware about different portions of it. So now the previous pipeline, if you see that was kind of a pretty simple in terms of we are just bothered about what piece of code we are writing. Over here, we define the routing, we write the controller, we write the action method, we generate the results for, and we configure the middleware. All these pieces we write, but there are a lot of other things which are happening behind the scene. So that if we know about that helps us in kind of handling various complex scenarios. If we go further, if you don't understand it, it's fine. Just try to observe or absorb as much as you can, and then probably spend little more time studying what is this or understanding this concept. So we'll look at this web API pipeline. If you see, so this APIs can be hosted in various ways. So it can be done in IaaS or it can be Azure, it can be self-hosted. So once you host the API, request comes over there. So where it is hosted, the request is handled differently on the hosting. From host, we get the HTTP request. So that HTTP request is it comes through the message handler. Inside that, first there is a delegation handler which looks at the request. Okay, this is kind of a request. Okay, which who should handle it? Where it should be further transferred? And then it sees, okay, what's the route of this? Okay, this request should go this particular thing. And then for each route, we can have different. Let's say if you want to do some pre-processing before it reaches the action method, or if you want to log that particular request, each and every request you want to log it somewhere, and you don't want to repeat that code everywhere in each of the action methods. So you can use those message handler to do that. And then you use the HTTP control dispatcher, which dispatches that particular request to appropriate controller. So, so we'll look at all this controller and action method and all. So everything will kind of fall in place once we kind of move further. So once we reaches the controller, then it initializes the controller, and first it calls the global filter. So global filters or filters are the thing which can be reused or which can be reused across different controllers or action methods. So filters can be like, let's say if you have some authorization or authentication logic. So you can write that in filter, and you can have, or you can put that attribute on top of class or on top of particular method, and that filter will be applied. So whenever that class or method will be called, so that filter will get executed. The logic will get executed. So let's say if you put authorization filter that uh, users with only this role can call this particular class or particular method, that filter checks that, okay, whether calling user has this authorization. No, it returns those 401. So at this moment, what you do is you written appropriate code. You don't say bad request because the request is good, but you are not authorized to make this request. So you written 401. So that's one example of filters. So this so it goes to filters, and then that action method has input parameter. So that can be model or a particular class. So that model binding happens. Then action level filter is applied. So global filter is which is across application. Then we can have class level filters, and then we can have action level filters. So same filter can be applied at any at different levels. So model binding happens. This is the action filter, which is that okay, you can call this class or you can use this class, but can you use this method or action? Let's say there is a doctor's class, you can get list of doctors, but there's an action method which says that can you create a doctor? You cannot create a doctor. So that action level filter can be applied over there, and then actual action, which is your method, and then you generate a result. So that result is converted. So when you make a web API call or API call saying that I need this data and I need this in this XML format, but over here there's no logic for XML or kind of a JSON. You are just returning an object. So what uh, web API does is there are a lot of formats which you can configure. So you generate a result and you can say, yeah, this is the result which I want to send. And then this web API framework understands, okay, this is the data which I got from action method, and this is the format which I want. I have been requested. So that data, if it's an XML request type, it converts it to XML. If it's a JSON, it converts it to JSON. So we can configure all those formatters at global level one, and web API takes care of all the conversions, and the HTTP response is being sent. So that's an kind of a detailed flow. So I'll quickly cover or repeat this flow again. So we get the request on hosting endpoint, then the HTTP request comes to the delegator, then through root dispatcher is dispatches to each root. On each root level, the delegation or message handling is done. Once that is being done, it identifies the controller. From controller, it kind of executes. It initializes the controller and executes the um, controller level filter or the class level filter. It binds the model, incoming model, and then applies the action level filter. Then actually execute the action, and then result and the result conversion is being done, and the HTTP response is sent. So you see over here, there's an exception filter. So we can configure exception filter at global level, which says that if there's any exception, and if there's any exception while in the entire flow, we can log that. We can handle that by exception filter. So those are global filters which are very powerful if you want to have a common logic which can be used across. Okay. So moving further. So I have one question. What is the scope of .NET framework in an AI application? So, so see, it, .NET framework allows you to do AI inside that. So you can write AI logic or artificial intelligence logic inside .NET application. So .NET application allows you to kind of write your code. There are a lot of libraries which you can uh, use it, or you can kind of refer it for if you want to do some of the AI calculations or logic in .NET, like other languages. But .NET framework allows you to write your logic and use various libraries. So that's the scope of the .NET application. You can pretty much do whatever you want to do. So this is in response to a question which came in Q&A. I'll type the answers later on. I'll continue with the session. Okay. So this is about the detailed pipeline. So we spoke about all these building blocks, but we'll specifically focus on this basic building blocks, which we generally, if you want to write it, a lot of other things. If you don't want to do spatial handling of HTTP message, you don't kind of write the custom HTTP message handler. So those are very rare cases that you want to do. But if you want to write a new web API, these are the things which you should be aware of, and you probably write it somewhere. Okay, controllers. So controllers are the classes which which has a logic for particular endpoint or particular set of endpoints. So and then controllers have methods which are called action methods. The methods which you mark as public and with specific attributes, those become action methods. But you can have other methods as well. So inside controller we have action methods. So now each action method is kind of a URI. Also, how this is being navigated, if, if a request comes, how that request is mapped to the particular controller, that is defined by a route. Now filters, as we talk about that, so there's this kind of authentication filter or exception filter, authorization filter, logging filter. So the common logic which you want to apply across different methods or classes, you can write that in filter. So services. So services are kind of a common services. So let's say a database, if you want to connect to a database, so that's kind of a service. Or let's say if you have some internal services which you inject, so you can register those services to one, and those can be injected over here. So and the pipeline. So what all things you want to use in web API? So that is defined once, or it is configured once, and then you generally don't kind of touch it unless you want to change it. So we'll see what are those. Okay. So uh, all right. So okay. The services and pipeline. So these are the six building blocks which we can which we'll probably touch upon. So I'm just starting a solution which I will be sharing, and then we'll look at the feature. Okay. So can any of the panelists confirm whether they can see the code window on the Visual Studio?
We are able to see the code, but I think that would do if you can just go through it very quickly.
Okay. Yeah. So I'll just show it so we get a feel of it. Okay. So we spoke about services and pipeline. So over here, and whenever you create a ASP.NET Web API, so this is developed in Web API ASP.NET Core, but it will look similar in ASP.NET other framework as well. So Web API ASP.NET Core is the latest. So if we look at this application, we all the common configuration generally happens on the startup. So on startup, we configure services. So there's like let's say there's a DB service, or there's some kind of an internal service, or there's some repository which we want to inject. So all this configuration are done over here. So let's say if you develop a new repository and if you want to use it anywhere, you just register it once, and it will be kind of injected at runtime directly by .NET framework or ASP.NET Core framework. Similarly, this there are kind of a lot of pipelines which you want to kind of inject. So most of them are kind of provided by uh, ASP, ASP.NET Core or ASP.NET MVC itself, but you have to tell ASP.NET, yeah, I want to use that. So, so those what are those? So let's say you want to use HTTPS redirection, or you want to use routing, or you want to use cross origin resource access. So if you want to do that, uh, you want to map your controller. So all those pipeline stuff you configure it over here. All the services you configure it at the top. So there are two different methods itself where you can configure. Now quickly let's take a look at the one of the controller. Okay. So a controller is derived from controller base, or in the ASP.NET MVC, this is called derived from controller base, but in ASP.NET MVC, without core, it is derived from API controller. Okay. So over here, if you see, we have all these interfaces. So we are not instantiating anything over here. All these are directly injected. So whatever is the implementation for this, at runtime, it will be injected over here. And how it is done, we look at iPut repository. iPut repository. It says that, okay, wherever this interface will be used, you use this class. So now if the interface says that, yeah, these are the methods, and you can change the class method. So from SQL, you can change it to Mongo, or you can change it to anything. So you can change your repository without impacting your controllers or the logic. So that's the power of injection. Also, while doing unit testing, this injection helps where you can kind of mock those injections. Now let's take a look at one of the get methods. So we have this method get. We say that, yeah, this is the get method. It has some parameters. So the parameters can be from query, can be from root, can be from body. So you can configure that. Okay. Once you get the parameter, you process this and you return say okay. So if you see this okay is the HTTP return status, which is 200. So we'll look at another one, single food. You want to, so this is for getting list. This is for getting single. So we say okay, it's a single item. So now for adding food, it's a post type. Observe this, it's a post type, add food, and if you say return, we return created at route, which internally it returns 201 status code. And we have partially updated, which is a patch. You see, partially updated. That's why it is patch. If it is fully updated, it would be put. And then you return okay. If you kind of want to delete it, you say delete, and you say no content. I don't have any content. So these are the kind of verbs and status code which are very essential. So yeah, so this is our action method. These are the route which we configure, and this is our controller. We have this kind of configuration at controller level. Okay. So also quickly execute this and take a look at how this is viewed. Okay. So here I've configured a kind of a tool called Swagger with my ASP.NET a web API. So that allows me to kind of that Swagger generates the API documentation, and it allows us to test as well. So let's say you see this, all these APIs are resulted over here or displayed over here. Okay, this get API. Okay, I can try it out from here. I can say, okay, version 1, I want to get all the data. I say request. So you see, I'm requesting this URL, and the response code is 200, and I get this data. Now, this is the data, but if you observe this piece of it, this is 8OS piece of it. So these are the links which generate, which says, okay, if you want to delete this particular food, you use this. You use this URI and you use this method. So if I say two, if it's a delete, if I say version ID 2 and version 1, if I say execute, it says yeah, it is deleted 400, 204. It says no content, but it is deleted successfully. The method is delete. So this Swagger is kind of a really good tool if you want to, if you haven't used it, I would say that use it while you do the API development. So I'll move back to presentation and quickly cover the remaining part of it.
We can go to the presentation and
Yes.
yeah.
Okay. So we talk about a lot of features. So what we'll do is we'll quickly see what all features are provided by Web API. So it supports HTTP, modern HTTP programming model, which we saw via different, how we can kind of control the HTTP request. We can return the particular responses, gateway generation and all. We can have strongly typed HTTP object model. So which by writing OK and returning that object, that OK strongly typed HTTP object which returns proper result. Content negotiation. So this is internally happens and while we get the request. Client and server negotiation about what are the data formats. So this is content negotiation is one of the negotiation which happens. Then default support for JSON, XML, and form coded URL, which we saw that it internally does. We can also add our own format. Model binding and validation, which we saw that yeah, in the pipeline it internally does. If you have input as a class object as an input, it does the model binding. It can combine, so you can have HTTP data or the FOCO. It's kind of a DTO model which you can have. You can have data validation via attributes. You can have routes, their mapping. You have full set of routing capabilities which you generally have in ASP.NET MVC. You can have filters. You can decorate web API endpoints for validations and all. So all those which we saw piece of it. That course configuration or authorization configuration which we saw some of that. Testability. So it provides IOC is for injection or the dependency injection. So it injects kind of objects at runtime. So that's why it's very easy to test as well. And we have flexible hosting as well. Okay, code walkthrough we already did. We looked at some of the methods and all. And we also saw it working. So some of the kind of uh, design pattern which we saw or which we looked at or discussed during this session. So this web API are very powerful or are the way to go where you want to develop microservices. If you have microservices which does particular piece, you can write web API, post at particular location, and then uh, it will return. So if you want to do microservices in .NET, web API is the way to go. There are other ways to do it, but if you want to develop microservices which allows you to exchange data, then web API is the way to go. It also web API also supports dependency injection by IOC containers. So you can use various such as various frameworks like Unity, AutoFac, and all. We also saw repository pattern where you inject repository at runtime, and that repository take care of object creation and updation and all. We saw mediator pattern where things happen on the pipeline and internally. We, are, there is a mapper pattern as well where let's say if you have data transfer object and you have actual business object, you don't have to write code. And if the properties are matching, you configure it in AutoMapper. It automatically maps your DT objects to a business model and business model to DT. And there are a lot of other patterns which we can use. hosting web APIs, we can self-host, we can host inside IaaS, we can host it inside Azure. Okay, so I think that is all. So open for questions, I guess.
Yeah, so we are open for questions. Any participant?
Yes, yes, go ahead. You can type your questions in the Q&A session or
You can type
Q&A
your
section.
question or just type a message. I can unmute if you want to ask the question.
Feel free if it isn't related with web APIs or if something other crops up in your mind that how this can be done or that can be done. Feel free to ask those questions. I'll try to answer to the best of my ability.
Yes, Yash, you have raised your hand.
Like if I create web API of CAPTCHA, so I need to so do I need to request to URL? See, URL is required, right? So whatever web API, so URL is Uniform Resource Locator. So whatever web API you host over the web, to be able to call that, you need to request that particular URL to have the data. So now I'm not sure whether your question is related to authenticating that web API via CAPTCHA. So if you enter CAPTCHA correctly, then only web API needs to be called. So that's a different kind of a authentication mechanism which we need to implement. But for calling a web API or web API which does anything, even CAPTCHA or anything, you need to call URL. Is that answer your question?
I have a question. How does web API differ from web services?
So web services and web API. So web services works on a SOAP based protocol, and it has a kind of a web methods as an endpoint, and which works on a SOAP protocol. SOAP protocol which uses XML. So and generally SOAP protocol or generally it is kind of a complex message packet, and it impacts your performance as well as not all clients can kind of invoke that. So let's say if you want to make a SOAP call from IoT or from very lightweight client, you cannot do that because not all kind of a client allows you to call that. But in terms of web API, that's a plain HTTP call. You can do it on pretty much any device which can communicate over the web.
And how about the security about web APIs?
Yes. So web APIs have kind of a lot of. So if you see the pipeline, so that web API pipeline allows you to use whatever security mechanism you want. So let's say if you want to integrate your web API with Google authentication, you can do that, or you want to do it with Facebook authentication, you can do that, or in fact, you want to do it with internal ASP.NET authentication authorization, you can do that. So that piece is configurable. You can use OWIN based any authentication mechanism, or you can use external server like identity server. So that's pretty much flexible. So that piece can be done using pipeline. So once you configure it in pipeline with appropriate configuration and implementation, so you can do that. So different authentication mechanism works in different ways. So let's say some of the authentication mechanism requires token in the header, or some of the authentication mechanism requires token authentication with third party. So that's depend upon our implementation. But generally, all the authentication happens using token. And when you make a web request or HTTP request, those tokens are sent along with the request, which is how the request is authenticated on server side. I hope that answers the question.
So one more doubt.
Yes.
So why we use Web API over WCF?
Okay. So WCF. So I would say that whatever you can do with Web API, you can do in WCF. Okay. But in terms of requirement, yes, you can do everything in WCF. But let's say if I ask you to develop a RESTful API with all those uh, kind of a RESTful architecture and all, if you want to do that in Web API and if you want to do it in WCF, the implementation and maintainability is the aspect where there's kind of a lot of restriction and a lot of time consuming is there. And also in terms of uh, various authentication mechanism, like if you want to configure a Google authentication with Web API and with WCF, the amount of effort it takes to get it integrated in Web API is a lot lesser than WCF, because WCF is designed in different way and Web API is designed defined in different way and in a lot more extensible way where you want to you have different use cases where it can be configured. And to that, I would like to answer one more other question. So where should we use WCF and where should we use Web API? Okay. So wherever you want to communicate over the web in a RESTful fashion in HTTP protocol, Web API is the way to go. But let's say if you want to have a TCP based communication where you are passing raw TCP bytes, or let's say you want to have a single endpoint where there is one Java endpoint which calls via HTTP, and there's a .NET client which calls you via TCP or name type protocol. So in that case, you will go for WCF where you want to support a variety of protocols. But if you are pretty clear that this is the way I'm going to call Web API or the API, and HTTP and the rest is the way, then Web API is the way to go.
Any more questions? So I think we can end this up here. Okay. Thank you, Ankesh, for your valuable
Thank you.
time and speaking
Yeah,
on Web API. It was
I,
really, it would maybe help our students and other participants to decide about whether to build an API or not. And if any one of you are more interested in learning how to build an API, you can anytime contact Oro University and Ankesh for the same.
yeah,
Thank you so much.
yeah. Thank you, everyone. Hope you had a good time and you learned some information which you were not aware of.